very much, Vincent. I didn't know it was a technical talk. No, just kidding. It's going to be a technical talk, and there is actually going to be some code on the screen even, I think. And yes, we are going to be talking about elegant data pipelining with Apache Airflow, and we'll dive into some paradigms of functional programming. Actually, Fokke will do that because he just loves functional programming and is a Scala lover. But we'll talk about Python, don't worry. This is PyData, right? That's what we do. To introduce ourselves briefly, Fokke, you might want to start.
Yeah. So my name is Fokke Driesprong. I'm a data engineer at Go Data Driven. What we do is helping companies to become more data driven. So I, as a data engineer, help companies setting up the data infrastructure. We also have a lot of smart data scientists like Vincent to help companies build nice predictive models. Bolke?
Okay, I'm CTO of Wholesale Banking Advanced Analytics, growing from 55 people now to 320 people in the next 3 years. So if you would like to join after this talk, talk to me. If you don't want to join it, I understand that as well, but that's all right. Work in a bank, for the ones that do not know what ING is, that's financial services. And we'll actually touch some of the subjects, and maybe you've heard the GDPR things. This is actually where our talks aligns a little bit, and it becomes maybe a bit interesting there. So Apache Airflow, what is Apache Airflow? Well, Apache Airflow allows you to, who knows Apache Airflow, by the way? Oh, that's bigger than the last time. Who doesn't know it? Okay, that's still like, 30% doesn't know. Well, Apache Airflow, and I have to say incubating between the brackets because we're still in the incubator of Apache. We're trying to get out, but we sometimes have a bit of difficulty doing that. It's a task-based workflow scheduler. We do this programmatically. So you might have, Uzi, for example, and I think Booking.com actually uses Uzi still quite extensively, is an XML-based scheduler, and Apache Airflow is a Python-based scheduler. So you'll create your workflows in Python. We do not really care what you run as your jobs, but the workflow itself is being created in Python. It was developed in 2015 by Airbnb. It was brought to Apache in 2016. And you can use it for ETL, machine learning, predictive, and generic pipelines. And it's used by about 120 plus companies, including ING, which I work for. Got a Driven spreads it around, but also Airbnb, Lyft, Reddit, PayPal, and a lot of other companies are using it. And we have a big amount of contributors, I would say, 460 plus. I think our largest, the part of our job for Apache Airflow is actually merging a lot of PR requests instead of writing a lot of our own code, because we can't keep up otherwise anymore. It's the speed by which it's being developed is a bit incredible. It's the downside and the upside of having Python, by the way, because it's easy accessible, but it's also easy accessible. So then people, try to do a lot of things. You might, I don't know if you know, but we are fully open source. There are some companies that actually build on top of Apache Airflow as a platform. Google has released Google Cloud Composer as a beta, which is Apache and Airflow underneath, and you can use it as a beta now. And Astronomer.io is having it as a platform. You can use that on AWS, for example, or Azure if you need it to be. Because not everybody knew what Apache Airflow is doing, and maybe you don't know how workflows, how they're visualized, and we talk about directed acyclic graphs. And you see an example of one behind me, or well, if you see it on the screen, you don't worry, you don't have to make up what all the parts are, but what you need to grasp that they can become pretty complex. This one is not even too complex. I've seen spiders that went everywhere, and actually ones that are too difficult for the visualizer to actually visualize, and then it basically kind of crashes. The scheduler still works, fortunately, but the visualizer can't handle it anymore. That's with thousands of tasks. Interestingly here, what you need to remember, or what should stick in your mind, some of the schedulers that you'll see around are about data scheduling. So every bit you will see here is basically waiting then for data. in this example here, and this is where Apache Airflow comes in, and what it is strong at, is also scheduling tasks. So if you see the white underneath, the white green one here, it says start cluster. Start cluster has nothing to do with doing data. It starts up a cluster, maybe in a Kubernetes cluster, or you schedule something on AWS, or you do something on-prem. That's all fine, but it has nothing to do with moving data around. It makes sure that you can start processing data, and that's something different than you'll see if you just move data around and you're doing your scheduling based on data only. So why is this important in the end? It is, well, ETL consists of a complex network of dependencies. You've just seen one, basically, and it's not just by data, it is also the things that you need to do around data that come into this as dependencies. And analytics and batch processing is still mission critical. Although we love streaming nowadays, for Booking.com, for example, to have the results of their A/B testing arriving late, people would probably get a bit nervous at the end of the day. For a bank, if we do not do our end-of-day processing in time, you probably won't receive some of your payments, or you would not have made some of the payments. Real-time paying is still a bit something that's in the future. These things happen at certain points at the day or in the week even. And because of that, even a lot of time, or too much time, is being spent on monitoring and troubleshooting jobs. We live in the real world, and we know that some of the servers might not be available for some time. And if your system requires you to jump on that right away because it fails at the first time, it can't reach that server, then you're going to be doing a lot of operational work, and you're going to have a lot of people standby for this. This is also where Apache Airflow helps you out, because it understands things like doing retries and waiting for data. It understands backfills, so you can change history. These kind of things are particularly created for a data era instead of something that was maybe some enterprisey feature for a particular big company. So when we were talking about, discussing this talk, so what does elegant actually mean? And why is this important when you build data pipelines? Well, firstly, it is about creating reproducible outcomes and pipelines. So the outcomes that you create through a pipeline need to be deterministic. And Focke will tell you a little bit around this, why well, functional programming will help out in this area. And they need to be idempotent. So when you run either part of the DAG or you run the full DAG, again, the outcomes need to be the same. So you can't have changing outcomes. That's important. They also need to be future-proof. So this means that you can do backfilling. And backfilling, we'll go into that a little bit later, allows you to actually change history because they are future-proof. And you need to do versioning, a versioning of your data and versioning of your code. And people forget very often that you need to version your data as well. And you need to be robust against changes, easy changes to DAG. So the world around us changes every day. And that you will be updating your DAGs accordingly will definitely happen. We assume that your DAGs will be slowly changing, so not like on an event-based change, but you still need to be able to add another task or remove a task and change history maybe even accordingly, or just continue in the future with it. And then finally, this is maybe what's becoming more interesting over, well, since GDPR introductions, but also since maturing, understanding what data engineering is about and what happens there, is that clarity where data resides and what it means and where it flows is actually quite important. It's not just important, for example, for the GDPR, but actually important for your data science. Where did that that one transformation happened? Why did it happen? What did it change? And can I do this again in the future, or can I do it again in the past? Actually, this is something that's probably still where we're looking for best practices. I take as an example here a lot of the what Michelle Utterford is talking about from Netflix. She's director of data engineering there, and she does really interesting talks around these kind of subjects. Is everything okay there? Oh, yeah, we make an impression, but I don't know if it's that big of an impression. So, Focco.
Yeah, thank you, Bolke. Are there any functional programming enthusiasts in the room? Like some Haskell people? No? I don't do it as well. It's too academic for me. Yeah. Scala? Yeah. Yeah. Scala is always a bit dangerous because if you see Scala people with a strong Java background, it's just like Java with the Scala extension. Yeah. So, but I think, yeah, from the functional programming world, we can learn some things that will help us write better and more robust ETL pipelines, or elegant as we call it. So when we do a transformation, we should look at it as a function with a defined input and a defined output. And if we have established this input-output, we can determine some kind of contract of what this operation should do. When we have this, it's much easier to test this operation in isolation, and we can just test this behavior with, for example, expected input, but also an unexpected input. Yeah, so when we look at transformations, yeah, what do we need to do to make this, to make these transformations pure, and also to isolate them from the environment? Is, for example, to make sure that there are no side effects. For example, in this top example, we see some global variable, some external state that we pull into the function, then increment it, and then return it. And ideally, you would something have like in the bottom one, like where you have all the state internally, and you just make a transformation as is. So you apply this transformation to the data. For example, this is a really simple example, of course, but in the real world, you sometimes see that stuff is being written to files, being read with other processes and stuff like that. Yeah, you want to keep this. You don't want to change data along with two other processes. You want to keep everything into one single operation, one unit of work. So what's important is also to be idempotent in your actions. So when you develop something, you have to make sure that the actions that you write are idempotent. For example, the top one, it doesn't matter how many times you execute it. The result will be exactly the same. But the bottom one, if you invoke it twice, you will undo the previous operation again. And this will result in some unpredictable behavior. So for example, if your task fails in the middle, then it's hard to determine where it stopped. So when you rerun it, it will be in an inconsistent state. You most probably will do some updates and you'll get with a really weird end result. Also, this is a really simple example, but sometimes when you do something like counting, you have to make sure that the counts that you do are idempotent. What's also really important when writing DAGs and Airflow operations, that you take the date into account. Like if you have something that has been run like 1 week ago, something changed, you want to rerun it, you want to make sure that you get the same result. So using Airflow, you can do templating. So for example, this is invoking an HTTP endpoint. You will get some currency data from CoinDesk with a set start date and a set end date. And this will guarantee, unless CoinDesk rewrites its history, it will always give the same result. But in the bad example, when you just get the current price, if you rerun something like a task that you're supposed to run like 1 week ago, we'll just get like the current price. What's also important is being immutable. So you should not see any delete operations, insert operations, upsert operations. When you process data for a specific period of time, you should just overwrite the whole partition. So instead of appending like additional rows, you should fix the logic and rerun the whole task to just overwrite the whole partition. So for example, what you end up with, that your sources have a specific date in there, and then the whole transformation of the whole pipeline will keep this date into account. So for example, if you have this is more like a data warehousing example where you have like some dimension tables and some fact tables that you want to combine. You just process all the dates that are the same. You can also see easily, like if you have something like this, it's easy to parallelize. Like for example, we process in chunks of 1 day, but it's also easy. Or we can also easily just run multiple days in parallel because they don't interfere with each other because there's no external state and they're not colliding with each other. This is something where we're heading to. Like with the whole GDPR stuff, we want to become more aware where the data is and what data are being stored. So instead of having all the metadata inside of your SQL scripts, we want to have one central store. For example, you can think of something like Hive, where all your metadata lives, and you can template this inside of your Airflow operations. So this makes it easier to keep track of where the data is being processed and what kind of transformations are being applied to the data. So when we take this into account, it allows us to rerun the pipelines for previous dates. For example, at the MPO where I'm currently am, we have some kind of parsing system for user agents. So we want to keep track of, what kind of people are using the platform, what kind of devices are they using. We actually use the user agent parsing of Booking.com to do that. Recently, I think it was updated because of a new user agent string of the iPhone 10. Then we update the code, and then we say, we want to reprocess 1 month of data because we didn't know of the existence of the iPhone 10 by then, but it could be that these strings, this data is in there. So we create a new version of the code, and we rerun this code over the past month of the data. This allows us to just rerun all the data with the iPhone 10 in there then. Having this in place is really important. First of all, to keep me sane. In the end, if you have like Bolke explained, like if you have this big visualized spaghetti on your screen and something breaks somewhere, and your task is not idempotent, you don't have any predictable behavior. It's hard to keep sane. And also from a legal standpoint, like we have to, if there's some result in the data, we have to have the ability to backtrace where this comes from. So this is always also very important that you keep predictable behavior. I think this is your slide again, Bolke.
Here we go. So we were talking a bit like creating, making sure that what's in your code is actually clear. So idempotency, reproducibility, all these kind of things, what Focko talked about and where we use the paradigms of functional programming for. However, you need to apply this to your data as well. So we talked about the partitioning, that you need to have the idempotency also available within your data. But also with GDPR involved, we like to also know where the transformations happen. And this answers if you talk about clarity, and we talk about clarity by lineage, this answers the following questions for developers, but also for the business users. So what is the latest version of the data that I need? So imagine that you're rerunning parts of your scripts, then is that if you had a model that was running on the previous set, will it generate a new kind of output because you rerun history, because you created new data from that? If that is actually the case, you need to know that. Because, for example, if we as a bank provide you with a mortgage advice, you can actually ask us, so how did you come to that decision? And we need to be able to explain it. If we changed history or we reran the data and we came with a different output for whatever reason, we still need to be able to go back into the past and explain you why we made that decision in the past, because obviously in the future new things might happen And you can do that, but you need to go into the past and explain why this happened. And even for auditing reasons, if it goes really very, very far, you need to be able to rerun that model on that old set of data and see if you indeed came up with that decision. So do you need to save versions of your data? Yes, you absolutely need to. And this can be done by snapshotting or by features that we're introducing in 1.10 plus in Airflow. So it won't be immediately all there, but some things are popping up and we actually need your help by code, please, or by best practices to understand how this really works, because I don't think the industry has come to a consensus yet how to do this properly. So you see things according with the big companies that they're trying things out, but how to properly do these things is still a pretty hard thing to do. It also answers questions, where did I get the data from? And this gets where it's, it's not only important for auditing reasons, but actually it's interesting for your data scientists as well. Because, if you have a certain data source, where did all the transformations happen and why did I get the outcome that I got? And what does it mean? Do I need to change that in the beginning to get a different outcome? Don't know. That's something that your data scientist will tell you eventually, and this is where they like that clarity to go back into your lineage and understand how that came to be. And eventually we need to store this somewhere, and for now that will be, we'll explain this in the context of Apache Atlas, which you might not be familiar with, but this is where you can store lineage information. And from 1.10 there is some basic, so in the master branch of Airflow, some basic integration with Apache Airflow, or sorry, with Apache Atlas. But what is lineage? And I'll put it on the screen here a little bit and I'll explain how it works. So we have a original data source called temp whole directory. And from this place, we run two bash operators, which correspond to an Airflow operator. And this bash operator generates new outputs, which we call contact, organization, and cross-references. And there's a date attached to it. And then another bash operator, in this case it can be anything, right, generates a final output. I don't know if you spot the problem here, because there's a problem in this diagram, because all the things that Foko talked about, they might not fully apply to the diagram I'm just showing you here. Does anyone spot it? I'll explain it.
Screens are too small, Bolke.
And the screens might be too small. Yeah, sorry. Good point. Good point. We should put bigger screens over there in the future. So you see that the original file does not have a date attached to it. And the final file doesn't have that either. So imagine this was running for 2 days because these are there. Imagine if I do that for a year. Then it suddenly explodes and we get 365 of these kind of blobs just attached to the whole direction in the final one. How do I get to an idempotent outcome and from my original source? I can't, because I don't know what's in here and how to split it up according to those partitions. So to make it elegant, as we talked about, there needs to be some changes to this to make that work. So let's build a proper pipeline. And imagine that you are using machine learning models that need conversion rate for currencies. So the example that Foko just gave you with, picking up something from CoinDesk, because we love cryptocurrencies, we like to invest into them, but we also like to have the predictions there to, when should I invest, when should I step out? Just a short example, and you can partially rerun it. And you then use this kind of outcomes for giving advice to your customers. You should never give investment advice, but in this case, for sake of the example, we'll do it here. And for your business, it is important though that you're able to explain to your customers how did you get to a certain decision. So versioning is important, and also going back into history. So bringing this together, our DAG consists of 3 tasks. It's a pretty simple one. Pick up the data, run the model, and put the outcomes at a place where it may make sense. We choose Apache Druid for this because yeah, it was there for fun. The DAG definition is quite simple. It has a start date of 2 days ago. We just ran it for 2 days. We call it build currency predictions, and it runs every day. This is a cron tab for the ones that might recognize. This is a daily cron tab. It runs at 12 o'clock for every day. So then we download the currency data. And for the ones that are familiar with Airflow, this is a bit of an updated kind of syntax that you can use somewhere in the near future. I'm not saying that you can do it right away, so don't try this at home now, because that won't work probably. But we're starting to have this in. So that you define inlets, which allow you to set the execution date, and as Focko earlier explained, and outlets, which in this case is a S3 bucket, and this allows you to specify the amount of versions that you'd like to keep. Airflow should automatically determine what version you are at, and then apply the new version and move the old ones out of the way if it's doing that. And you specify the HTTP operator, gets the currency, determine the inlets and the outlets. So this picks up, because we talked about the idempotency part. We can run this independent from anything else. It will pick it up, it will put it there, and it puts it at the right place right away, with a version even. Then secondly, we run the machine learning model. We assume it's just run in Spark. It's pretty simple. We have one outlet, because the interesting thing is Airflow is aware of the previous outputs. So you don't need to specify the inputs anymore, because if you say inlets are automatic, okay, sure, Airflow will pick those up and use them as inputs for your script. And the outlet in this case is determined. We're looking at how to do this automatically and obtain this from Spark. It's a bit hard because the infrastructure is not really there for it. But we can pick up the outlet or define it manually. And we call it create currency predictions. And we set the upstream for this task, of course, to the previous task. Then finally, we drop the table into Druid. And we do that by a table. And you can actually think of the files already as tables. So thinking about that in the future, you could say, okay, we'll just have tables with files as a placeholder where the location is. But we create a Druid operator. Again, it has max 5 versions for the invest predictions table. And we create the auto inlets again. So it's automatically determined again. It makes it easier for you as a developer, right? There's not a lot of metadata programming, and it actually helps you to do it properly. And we create a new outlet, which is the predictions here. And we set the upstream. So what does it get you? So this is the one on the top. This is what you'll see for now in Airflow. So this is pretty simple. This is just the DAG. And it has the get currency, get predictions, load into Druid, because that's what we just talked about, right? And this is how it connects. This one is the create predictions is dependent on get currency, load into Druid is dependent on create predictions. If we go to Atlas, however, now, then you'll see, hey, I'm picking up something from CoinDesk, and the name is not really clear in this case, but this one corresponds to get currency. It outputs something to a new S3 bucket. Oh, it's there. You can see what it's doing. Create predictions corresponds to the next operator here. Creates a new S3 bucket, and then we end up into Druid. If you would rerun this the next day, you would get the same line. So instead of that it explodes in a graph eventually, no, you will get it for the same for the partition. You get the same line every time. That makes it an elegant pipeline, because that makes it very clear where your data resides, and it won't get as complex that you have a difficulty finding where your duplicate data might be or these kind of things. So concluding. Please build pipelines that are idempotent, deterministic, have no side effects, and use immutable data sources and destinations. Don't do updates, appends, or upsert, or anything else. Make sure that you version your data, and make sure that you version your code accordingly. Thank you very much. Yes, we're hiring. You can talk to Focco or me. Yes, we're competing. That is also true. But we like each other too. Don't worry. All right. Cheers, guys.
Awesome, thanks. I like the idea of not having to write the disk in Airflow anymore. Quick thing, we still have some time for questions, but if you ask the question, speak up a bit and please repeat the question.
Sure.
Does anyone have a question in the back?
So talking about determinism, how do you handle package dependencies? We used Airflow a while back and we struggled a little bit when porting code from local production to development and production, making sure that all the package versions were the same. Sometimes we needed different package versions for different jobs. So for example, currently we use something like depend for
Yeah. Yeah, I think I know where this question will be going. So I'll repeat it. Yeah, don't worry, I'll repeat it. I'll do that. So you're basically asking how do we handle package dependencies if we need to do idempotency. Yes, this was, and it still is a bit of a challenge. In the Python world, these kind of dependencies are more difficult to handle. However, with the new Kubernetes executor, that's also in 1.10, you are actually able to specify the dependencies per task now, and that will, with the containers created from that, those will be idempotent. So yes, understood that question, and there is, well, we're getting to a solution.
Yeah.
Any other questions? In the back first, then you.
Will the package in Atlas work over multiple DAGs as well?
No, sorry, I'm not looking at Focco. Focco can't answer the question. Yes, it will. I mean, oh, you will? You can?
No, I'm not Atlas expert.
No, that's sorry. Don't. I'll repeat the question. Sorry, guys. Sorry, Focco. That was not the idea. So the question was: will Atlas actually be able to handle the across different DAGs? The lineage across different DAGs. Yes, obviously it will, because basically Atlas itself determines its lineage according to the inputs and the outputs that are being created and attached to a certain data source. So in this case, and I'm not a Atlas expert, by the way, if you can integrate with Airflow only, but there's a lot of integration work being done on Hive. There's a connector for Spark. There's connectors for a lot of other systems nowadays as well. And eventually it will go what they call open metadata exchange. It will actually allow you to go across different lineage systems. So they'll do something with IGC. There's an IBM component which is more used in enterprise context. So as long as you reference the right locations for Airflow, then it will be able to determine what the lineage was across DAGs. Any other questions? Sorry, there was one here in front.
Yeah, I have a simpler question. I have seen one parameter which was maximum versions for output file.
Yes, you did. So maximum versions of output files, you saw that as a new parameter. Yeah.
Yeah, can you also specify a time frame rather than number of files?
It's a good question. So you're asking whether you can, instead of for the versions, you can use time frames. Well, not yet. Actually, the max versions right now doesn't work yet. It's still something that needs to be implemented. So that's actually a good suggestion.
Yeah, because at the end you need to version your data, your output data as well, and yeah, if you can't have a control over the output file, if they are being overwritten with subsequent pipelines, then yeah, it would be difficult to keep track of the version, I guess.
Yeah, so the idea around, so you say that those files might be overwritten. That could be the case. It is actually up to the developer or to the company to determine how they want to implement this. So it probably depends on the company how to do it and the policies around it. Airflow is not going to be strongly opinionated about it.
We have time for one last question because we don't want to be between you and coffee. Last question?
I see, yeah, you were first. Here we go.
How do you handle data transmission between the tasks for different executive backends?
Say again?
How do you handle the data transmission of the in and outlets for different executive backends?
We don't. So the question is, how do we handle the different executor backends and then the data inlets, outlets? We don't support different executors at the same time. So Airflow doesn't do that. So I don't fully understand your question, I think.
For a particular executor, for example, how do you transmit the data between tasks?
In the end, Spark is only a workflow orchestrator. So Spark will orchestrate your workflow, keep track of everything, get the logs. But in the end, for example, if you do a transformation, it will be done in Spark. So then you will read from a bucket, process it in Spark, and then write it to another bucket.
Maybe to clarify,
Yeah.
it's only metadata that's inside the inlets and the outlets. And there's no data at all, because that won't work. That's not what Airflow is for. So we're concluding, right?
Please give a final.
Thank you.
Sorry, man.